Hey guys, Mr. Riz here to help you out on the next section in Algebra 2. So in 2.2, we're looking at linear and nonlinear functions. So the key thing here is that linear functions are functions whose graph is a non-vertical line or part of a non-vertical line. So basically, we would have a function that would have a nice straight flow through it, whether it's going, up or down, or it's just flat. It just can't be straight up and down. I mean, clearly from the name linear, you're going to be looking for a line. And then on the other side, nonlinear functions are graphs whose line is not, or whose function is not part of a straight line. So anything that has a curve in it or a bend to it. So you can see here, we got a nice parabola that's nonlinear, or a cubic function here, once again, nonlinear. Now, even though this next one, which would be like an absolute value function, is made up of two straight lines, it's not one straight line. And so that would be a nonlinear function. So linear functions has, let's see if you guys can try to figure this, has a what in its table of points. And so we can look at the following here. So what we're going to be looking for to determine whether these are linear or nonlinear is that there's got to be a pattern. And it's got to be like straight up like an addition pattern, not like a ×2 or anything. That would actually be another type of function we'll learn later on in the year. But we're going to be looking here. So if we look here, our x's are going up by 2. Okay, that's good. And then we got a +3, then we +3, +3. So this one here would be linear. All right, we're looking just for an addition set every single time. All right, here we're going up by 1 here. Let's see, this would be a -2, -2, -2. Okay, so that one would be linear. All right, this one here, 0, 1, 2, 3. And then if we look, okay, we did +1. All right, +3, +5. Okay, not following a pattern here. So we would say that this one is nonlinear. Okay. All right, now that we understand that we're going to have a graph and we're going to have to find, or going to have a nice line, the two things that we want to find are the x and y intercepts. And if you forgot, the x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-intercept. Now, it could be above or below or left and right, but there's an easy way to figure this out. The x-intercept is always at some number a comma 0, and the y-intercept is always at some number 0 comma some number. We typically use like a and b to represent those. Now, to find the x-intercept, what we're going to do is we're going to find the equation here, and we're going to find both of them on these. To find the x-intercept, we need to make the y equal to 0. So we're going to do 2x plus 3 times 0 equals 18. All right, now we know that 3 times 0 will just go away. So that's gonna, I'm gonna cross this off here because that's gonna be 0. So we get 2x equals 18, and then we divide by 2, x equals 9. So the x-intercept on this problem would be at the 0.90. The y-intercept, what we need to do for that is to make x equal to 0 and solve. All right, so we're going to have 2 times 0 plus 3y. So if we're trying to find the y-intercept, we're going to get rid of the x and solve. We're going to try to find the x-intercept, we get rid of the y and solve. All right, so let's see, that goes away and we get 3y equals 18. If we divide both sides by 3, y would be 6. So y is the second number, the y-intercept's at 0, 6. If you guys want to pause the video, try the next two on your own, you can. If not, I'm going to walk through them. All right, so let's do the x-intercept here on this one. To make the x-intercept, we're going to make the y equal to 0. All right, now this problem doesn't go away, it just becomes 0. We need to add the 30 over, so we get 30 equals 5x, and then we divide by 5, x would equal 6. So the x-intercept is at 6, 0. And the y-intercept, all right, we're going to make the x equal to 0. All right, 5 times 0 is 0. So we get y equals negative 30. And, well, we don't really need to divide because that's a plain old y. So we'd have a y-intercept at 0, negative 30. All right, once again, if you want to pause, you can. Let's see if we do this one here correctly. The x-intercept, we're going to make the y equal to 0. So 6 times 0 equals 36. All right, so that goes away. We get 4x equals 36. We divide 36 by 4, we get 9. So we get a point at 9, 0, just like the first problem. And then if we do the y-intercept, we're going to make the x equal to 0. All right, that's going to go away and we get 6y equals 36. And then our y equals 6. And holy cow, that is the exact same x and y intercept of the first line. One thing we'll talk about later on, these two are actually the exact same equation. If we just multiply every number by 2, we get the same equation. So it's the same line. Something that's going to happen later on in the chapter. Okay, so we got a couple practice problems here to wrap up the section. So go ahead. You're going to look at these here versus the table or the graph to determine whether these are linear or nonlinear. And then you have a practice problem on your CYU to determine the x and y intercepts. All right, guys, thanks for watching. I will see you for the next section.